Hello everyone, Rain1290 here, bringing you another thunderstorm risk analysis. Yes, there is a thunderstorm risk for southern southwest Quebec and eastern Ontario, extreme eastern Ontario, upstate New York. So this will be for June 7th. It's the first thunderstorm risk for June. And yeah, let's go into why that is. So if you find these types of videos useful, I highly encourage you to subscribe so you do not miss out on upcoming videos, because I will be producing more of these thunderstorm outlooks going forward on my channel and perhaps for other weather events. So if this is something that interests you, again, I invite you to subscribe. Okay, and be sure to stick around to the end of the video for more details of thunderstorm hazards and other attributes that will be covered at that point and in between as well. Okay, so looking at our average cloud cover for tomorrow, so you can see a lot of breaks in the cloud deck as we go forward throughout tomorrow. So anything in white represents cloud cover, and anything, the darker patches represent clear breaks. So as we're going more into tomorrow, so this is tomorrow now, and you can see that there are plenty of breaks, so plenty of clear breaks to let the sun get through and destabilize the air in this region, Eastern Ontario, Southern Quebec, extreme upstate New York. Okay, so consistent with the average cloud cover that I showed previously. So let's look at the low-level lapse rates to see if that reflects well those breaks that I mentioned. So going into tomorrow, this is tomorrow early morning, so we don't expect low-level lapse rates because there's no sunshine during the pre-dawn period. So going to late morning, you can see those low-level lapse rates starting to steepen. So these brighter colors, especially the red colors, represent the steepest rates. So you can see that overspreading the regions in question, and now especially some purples taking place in southern, southwest Quebec and eastern Ontario. So that's reflective of the amount of sunshine that's getting through. Now, I want to stress that this could be a bit overdone because there is smoke, the wildfire smoke coming in from the west that's overspreading the region. So this may temper these rates a little bit. So in essence, these models may not be taking into account the extent of smoke accumulation that's actually getting into this area, again, because of those southwest, west-southwest winds aloft. But nevertheless, that smoke thickness is expected to be fairly thin, so I don't expect it to temper these rates too significantly. Okay, so this animation shows the amount of particulate matter, fine particulate matter, PM 2.5, that's originating from these wildfires, these western wildfires. And pretty much as you've probably noticed over the last few days, this has been fanned towards the east. So the last few days have been on the hazier side because of the smoke accumulation. So as I mentioned, I think this will have some limiting factor on solar heating tomorrow. Nothing too significant. As you can see, we've been having, this is measured in micrograms per cubic meter. So we've been having anything from 1 to 28 micrograms per cubic meter. So tomorrow we are seeing a somewhat thicker amount of particulate matter overspraying the region, but I don't think this will have a significant effect on thunderstorm development during the mid to late afternoon. Okay, so switching gears to the mid-level lapse rates. So these are much like the low-level lapse rates, except they're taken at mid-altitudes of the troposphere. As we go forward in time, you can see these steeper mid-level lapse rates starting to also overspread Eastern Ontario, Southern Quebec, upstate New York into tomorrow afternoon, which is when these thunderstorms are most likely to develop. So ideally, what you would want at least 6 Celsius per kilometer, that kind of cooling rate to take place at those altitudes. So we're actually seeing that in these regions. And to complement the low-level lapse rates that I showed previously, this will help to amplify instability. Okay, so now looking at the surface dew point. So these colors represent the amount of moisture that's in the air near the surface, near the surface. So it's represented again by the dew point, and the dew point is a quantity that gives us an idea of how much moisture is in the air. So these green colors, but especially those blue colors farther south, represent the highest humidity or the highest dew points. Now in southern Quebec, eastern Ontario, upstate New York, so as we go further in time, so you can see that we're getting some decent amounts of humidity in this area. Nothing too big. Ideally, you would want the blue colors, not the greenish so much, but the greens are decent, representing dew points in the low to mid 50s Fahrenheit, which is approximately 10 to 15 or 10 to 14 Celsius. So it's not particularly high humidity, but it's at least moderate tomorrow afternoon. So putting together all of those factors that contribute to instability, the dew point, the low-level lapse rates, the mid-level lapse rates, we want to try to put that together into one metric. And one way to do that is through CAPE, convective available potential energy. Right, so it's a metric of instability. So when we amplify the low-level lapse rates, the mid-level lapse rates, we boost the amount of moisture at and near the surface through higher dew points. We can magnify the total instability factor. So as we go further in time, so this is through, well, you don't expect instability in the morning because there's no solar heating. Or much instability anyway. But as you go farther in time, into later in the morning, into the afternoon, you start seeing these purple colors starting to emerge, which represent higher amounts of instability. So we have an instability or CAPE value, which is measured in joules per kilogram of around 500 joules per kilogram by tomorrow mid to late afternoon. So, and this is not particularly high. I think it's restricted especially by the somewhat limited amounts of moisture. So as I mentioned, the dew points of around 50 to 55 are borderline low to moderate humidity. So that does help to limit how much CAPE there would be. But it's still surviving through especially the steepened low-level lapse rates and the mid-level lapse rates, and still decent humidity at the surface. Okay, so turning our attention to surface moisture convergence, this is a means to evaluate how strong any surface boundary might be, like a cold front or a warm front. So we're looking for these brighter colors, like the reds and the ambers or the yellows, as a way of pinpointing the greatest amount of lift. So this is tomorrow morning. So you can see this is to get our bearings straight. So the Montreal area is here. This is Eastern Ontario, upstate New York to the south. So as we go farther in time, we don't really see all that much lift taking place, as represented by these subtle green colors and lack of color altogether. So this indicates to me that there are no frontal boundaries, no cold front, no warm front. So if there is to be a thunderstorm development risk, there may be other factors. So let's look at those other factors. So as further reassurance, we don't really see the presence of any kind of frontal boundary, no cold front, no warm front. So these are your warm fronts, these reddish, the semicircled kind of lines, and the cold front is represented by these spiky blue lines. So we don't see really any of that taking place. This is for later tomorrow. So there's nothing really at the surface to help thunderstorm development. And so this further reinforces the idea that the subtle shortwave trough that I showed previously is the primary factor that will help to control the amount of lift for thunderstorm developments, isolated thunderstorm development altogether. Okay, so now this is looking at another source of lift. So these can be often in the forms of shortwave troughs or longwave troughs, and we evaluate these at the 500 millibar altitude or closely related altitudes, because that's where these are assessed. So again, just like the surface convergence parameter, we're looking for the brightest colors like the reds, the blues, which are the maximized amounts of lift at these altitudes, and yellows. And we're, again, not really seeing all that much as we go farther in time into tomorrow. And this brings us to tomorrow mid-afternoon, mid-late afternoon, and we're not seeing all that much like the surface convergent factor that we looked at previously. However, what I want to bring your attention to is the subtle area of lift that appears to be taking place with an ill-defined shortwave trough. So this could actually be the focus for isolated thunderstorms tomorrow. Okay, so looking at this skew-T log P diagram, so shout out to Sky of the Universe for correctly identifying what this plot is. It's also known as a tephrogram, so it all means the same thing. So really what it's showing us is how wind speeds are changing with increasing altitude and wind direction as well. So we're located over here at the surface at the 1000 millibar pressure, constant pressure level. And what it's showing us also is how temperature is changing with increasing altitude, the ambient temperature represented by this red curve. The green curve shows us how moisture is changing, represented by the dew point. So that's this green line here. So you can ignore the blue line for now. And again, eventually I will do a video at your suggestion about how to properly interpret this and what it all means. And yeah, that could be a very interesting video going forward. Okay, so pretty much all you need to know from this is that this blue dashed curve, which represents the parcel temperature, is to the right of this red curve, at least along this vertical depth. So when that happens, you have instability because the parcel temperature is warmer than the environmental temperature, which amplifies buoyancy. And then this causes parcels of air to actually start rising. So that's pretty much how you would read at least the instability factor. So this whole region here, this gap between the red curve and the blue dash curve is what we call CAPE. And in this particular case, we have about 1600 joules per kilogram because that's how CAPE is measured. So it's actually about 3 times as much as the CAPE that was shown on the other graphic that I displayed previously. But regardless, so the cape itself doesn't extend over a great vertical depth. It ends up just below the 300 millibar altitude, which is near the, not too far away from the tropopause. But ultimately, this represents a pretty shallow, somewhat shallow vertical depth. So I don't expect thunderstorms to be particularly tall in tomorrow's environment. And these shearing fields also indicate that thunderstorms won't be too organized because we have a very sloppy change in wind direction with increasing altitude, although they have a decent speed around 500 millibars. So it does suggest at least some organization, although nothing too robust. So ultimately, just eyeballing this entire profile based on wind speed direction and the temperature profiles, I don't expect too much organization. I don't expect thunderstorms to be moving too quickly, and I don't expect them to be overly long-lasting. Sort of profile also emphasizes the idea of more breaks in the cloud deck. And one more attribute that I wanted to point out is if you notice the 500 millibar temperature. So this is approximately 500 millibars. 500 millibars. So if we follow it this way to the red curve, and if you follow it diagonally down, because that's how we read these profiles, these temperature profiles, and that equates to approximately minus 18 Celsius. So that's about there, right? So you follow it back up to the red curve, it's about minus 18, minus 17. So what that indicates too that at least at maturity or close to maturity, that some of these thunderstorms, especially when they're fresh, will have some chance to produce some small hail. So I do expect a bit of a small hail risk. So starting with that shortwave trough, since that's the principal lifting mechanism, even though it's not particularly high lift, it's very subtle lift, but it might be enough to help realize the instability that I mentioned previously in this QT log P diagram. So I expect thunderstorms to sort of form in this area and in an isolated fashion, as we mentioned, and move in a very subtle southeasterly direction. So moving very slowly in this direction. So I target this area because that's where lift appears to be maximized, even though it's a very subtle amount of lift, as I mentioned. I don't expect them to have a particularly long lifespan. So as they reach the New York border, I think they will start to dissipate in large part. So this is mostly a mid to late afternoon event. Okay, so to provide a summary of June 7th situation during the mid to late afternoon, so I expect thunderstorms to follow an isolated coverage. So not too many thunderstorms are forming in this environment, mainly because the lift is pretty weak with that shortwave trough. And also the thunderstorms will be non-severe. That being said, there would be a small hail risk. So there's some risk, some narrow window of opportunity for some hail, especially to the northwest of here where initiation is occurring, most likely. The thunderstorms themselves will mostly be capable of heavy rainfall. I think this will be the dominant hazard. Lightning frequency will be mostly occasional, so not too many lightning strikes per minute, per several minutes. The thunderstorms, again, will be slow moving and they will be briefly sustained. So there you have it. That's pretty much the risk assessment for June 7th in Eastern Ontario, especially Southern Southwest Quebec, where I think the thunderstorms will be most prominent. Yeah, so until the next risk, I will see you in the next video. So thank you very much for your attention once again. And yeah, please feel free to leave your comments and questions below. I'll be happy to address them. And don't forget to like this video, subscribe if it is of interest to you, if you would like to see more videos like this going forward. And once again, many thanks.